In this lecture, we are going to discuss about geometrical meaning of zeros of polynomial. First, we will see what is the zero of a polynomial. If any polynomial p of x is given and there exists a value real number k such that p of k is equal to 0, then k is called the zero of polynomial. The same thing we are going to see geometrically. So for any linear polynomial, first we will take a polynomial with degree 1, that is called linear polynomial, and we represent it as ax plus b, where a is not equal to 0. In this case, if we want to find out the zero of this polynomial algebraically, we will make the polynomial as polynomial equation. So that is p of x is 0. Then in place of that, if we substitute, we can get the value of x. So a linear polynomial can have 1 0, that is minus b upon a. If we take a specific example, p of x is equal to 2x minus 4. And if we discuss the zero of this polynomial, then by making it as a polynomial equation, we can easily get the value of x as 2. This value of x is algebraically, we can say, zero of polynomial. The same thing if we have to represent geometrically. Then this p of x we will replace by y. Why we are doing this? Since we have to represent this polynomial geometrically. Geometrically means in Cartesian system. So if you want to represent any point in the Cartesian system, you should have x coordinate and y coordinate. So because of that, we are taking this p of x as y. So now the situation is y is equal to 2x minus 4. So if we notice, this becomes an equation in two variables for linear equation. And we know linear equations representation in graph is a straight line. That also resembles with linear. Linear means line. So for that we require at least 2 points to represent this equation in the graph. So we will find out two solutions, x and y. For x and y, we will take any value of x and we will find out the corresponding value of y. First, suppose we are taking x is equal to 0. So y will be 2 into 0 minus 4, that is minus 4. So for x is equal to 0, y is minus 4. Now let's take another value, x is equal to 1. Then in this case, y will be 2 into 1 minus 4. So that is 2 minus 4 minus 2. So when we are taking x as 1, the value of y is minus 2. So these are the two solutions of the equations, and we may say the points which we have to represent in the graph. Now if we represent these 2 points in the Cartesian system, for Cartesian system we have to take 2 axes, x-axis and y-axis, and we will take these 2 points 0, minus 4. So this x coordinate is 0, that is why this point will lie on the y-axis. 0, minus 4 is this point, and 1, minus 2. So here 1, minus 2. Minus 2 will fall over here, 1, and this is 2. So this is the second point, 1, minus 2. Now by taking these 2 points, if we join and draw a line, we will see that this line is going to cross or intersect the x-axis. That point is very important, and the x coordinate of that point will be called geometrically the zero of this linear polynomial 2x minus 4. Because the meaning of zero of a polynomial geometrically is x coordinate of that point where the line or the graph touches or intersects the x-axis. So here we can say geometrically this is point, suppose A, and this is 1, this is 2. So this point's coordinates will be 2, 0. So x coordinate of this point is 2. So 2 is the 0 of this polynomial p of x to x minus 4. We will see now how can we represent a quadratic polynomial graphically or geometrically. Any quadratic polynomial can be written as p of x is equal to ax square plus bx plus c, where a is not equal to 0. Now to represent this graphically, first of all we have to again write this p of x as y. Let's take one example. P of x is equal to x square minus 3x minus 4. If we see algebraically, then to find the zeros of this polynomial, we have to factorize it. And we can factorize by using splitting the middle term. Here, minus 4, we have to take two factors of 4 such a way that the multiplication is minus 4 and addition is the coefficient of x, that is minus 3. So what are the two factors we are taking? Minus 4 and 1. So x square minus 4x plus x minus 4. Now take x common. This will be x minus 4. 1 common, x minus 4. So the two factors are x minus 4 and x plus 1. So algebraically what we have seen, there are two factors, and if we want to find out the zeros of this quadratic polynomial, again we have to represent this polynomial as its polynomial equation. So if we are writing p of x is equal to 0, it means that x minus 4 into x minus x plus 1 is equal to 0. Then either this is equal to 0 or this is equal to 0. So first case, x minus 4 is equal to 0 will give us x is equal to 4. And secondly, x plus 1 is equal to 0 will give x is equal to minus 1. So the factors are x minus 4 and x plus 1. But the zeros are 4 and minus 1. This is algebraically. The same thing we can do geometrically or graphically. So to represent this quadratic polynomial, we have to find the solutions same way. What will we do? Y is equal to x square minus 3x minus 4. Always remember this y is p of x. So we will find out few solutions, and after finding the solutions, we will represent those solutions as points in the graph, and that will be the representation. So now let's see. First, if x is equal to 0, then y will be 0 minus 4, that is minus 4. So the first value we are getting 0 minus 4. Second, if we are taking x is equal to 1, then y is equal to 1 minus 3 minus 4. So that is minus 6. Third, if you are taking x is equal to minus 1, then y is equal to minus 1 square, then minus 3 into minus 1 minus 4, that will be 1 plus 3 minus 4, so that is 0. So when we have taken x is equal to minus 1, we are getting value 0. Similarly, x is equal to 2. X is equal to 2 will give us y is equal to 3 into 2 minus 4, so that is 4 minus 6 minus 4, so that is minus 6. Similarly, we can go for few more values, because in the quadratic polynomial we will notice it will be a new type of curve which is called parabola. So for that we require more values. That is why we are finding values like this. So minus 2. So x is equal to minus 2. So y is equal to minus 2 the whole square, 3 into -2 minus 4. So 4 plus 6 minus 4, that is 6. Okay. Now these are some values which we have got, and these values we have to represent on the graph. This is the Cartesian system. Now we will take few more values to show the graph. Let's take y is equal to 3. X is equal to 3. So by taking x is equal to 3, y will be 3 square, and then 3 minus 4, that is 9, minus 9 minus 4, so that is minus 4. So for taking x is equal to 3, what have we got? Y is minus 4. Let's take one more value. X is equal to 4. For that, y will be 4 square minus this, so that will be 16, minus 3 4s are 12, minus 4, 16 minus 16 gives us 0. So for taking x as 4, y is 0. Now these are the points which we have to represent in this graph. Y-axis, x-axis, this is the origin. Now let's take the point 0, minus 4. 0, minus 4 will fall over here. So that is point 0, minus 4. 1, minus 6. This is 1 and this is 6. So this will be 1, minus 6. Next is minus 1, 0. This is minus 1. We all know this is negative. This side is positive. So minus 1, 0 is this point, minus 1, 0. Next is 2, minus 6. So 2 is here, and 2, minus 6 will be coming with this. So we will just rub this, and 2, minus 6 will be here. So minus 1, 6, 1, minus 6 and 2, minus 6 side by side. Now, next is 3, minus 4. 1, 2, 3, minus 4. So this is the point 3, minus 4. Next is 4, 0. 1, 2, 3. These are the 2 points which are on the x-axis, and these are 2 points, and these are 2 points. So total how many points we have marked? 1, 2, 3, 4, 5, 6 points. If I rub the coordinates and you can only see the points, will be more clear to you. So in this case, if you just join these points a freehand curve, that curve will be called a parabola. This kind of curve is called parabola. This parabola, what we have got, you can see, is intersecting this x-axis at 2 points. One point is 4, 0. Another point is minus 1, 0. So the definition of zeros of quadratic polynomial or any polynomial is wherever the curve or the freehand curve or the straight line cuts or intersects the x-axis, that point's x coordinate is called the zero of the polynomial. So here there are 2 points. Let's give the name A and B. So point A is 4, 0 and point B is minus 1, 0. So what is important? 4 and minus 1. So there are 2 zeros of this polynomial, 4 and minus 1. So what we have seen algebraically or geometrically, we can say the zeros of quadratic polynomials are coming 4 and minus 1 for the quadratic polynomial x square minus 3x minus 4. Now this parabola is called opening upwards. Okay. Similarly, there are different cases. We will see that this parabola can open downward also. So one more example I'll give you. Now see this example. A quadratic polynomial is given, but the coefficient of x square is minus 1. The previous one what we saw was x square minus 3x minus 4. Here the coefficient was positive, and when it is positive, the parabola was in this shape. Now we will see in this example, the coefficient of x square is minus 1. And these are the solutions of these two. We will find out How can we plot these points? Now let's see. Minus 4 comma minus 5. Minus 4 comma minus 5 will fall here. 1, 2, 3, 4, 5. So this is the point. Minus 4 comma minus 5. Minus 3 comma 0. 1, 2, 3. Minus 3 comma 0 is this. Then next is minus 2 comma 3. Minus 2 comma 3. 1, 2, 3. So minus 2 comma 3 is this point. Then next is minus 1 comma 4. Minus 1 comma 4. 1, 2, 3, 4. This is the point. Next is 1 comma 0. So this is the point 1 comma 0. And 2 comma minus 5. So 2 comma 1, 2, 3, 4, 5. Now if you look at these points and if you join it freehand, then we will see that this particular graph, this 0 comma 3, I just forgot, 0 comma 3 will be 1, 2, 3, this point 0 comma 3. If you draw this graph, then we will notice the freehand graph is opening downwards. So this parabola is of shape opening downwards. So it depends on A. What is A? In quadratic polynomial, A is the coefficient of x square. So first case, when A is positive, the parabola is opening upwards. If A is less than 0, this case what we have taken, A is minus 1, it is less than 0, so parabola will open downward. So these are the two factors on which we can decide whether parabola will open upward or downward. There are many other cases. Means if in Cartesian system we look at the types of parabolas, the different situations I am giving you here. Suppose the parabola touches in this way or in this way. Earlier what we have seen, the parabola was intersecting the x-axis at two different points. This was the case either this way or this way. Means these are the 2 points which will give us the zeros of the quadratic polynomial. And in this case, the parabola is touching the x-axis, isn't it? It means that this A and A dash will coincide. Okay? So, this point A is actually A, or you can say A and A dash merges. It means the same 0. Now, same 0 means, for example, I'll give you P of x is equal to x minus 1 the whole square, and its expansion will be x minus 1 into x minus 1, isn't it? It means that there are two factors and both the factors are same. In this case, the value of x is 1 and 1. It means the same value. Okay? When this is the same value, that point A and A dash what we were discussing is the same point, and that point will be here 1 comma 0. It means only 1 0 is there. And 1 0 is there, so that type of parabola will touch the x-axis at a point 1 comma 0. So this kind of parabola you are going to get. Similarly, we can get any other parabola which can touch the x-axis at exactly 1 point. So a quadratic polynomial can have at most 2 zeros and minimum 1 real 0. There is third case also. The third case says, suppose the parabola is not touching or intersecting the x-axis at all. it means that we will not be able to get the real zeros of these kinds of quadratic polynomials. Now in this case, quadratic polynomial, let's see some special cases. Y is equal to x square and y is equal to minus x square. It means this polynomial is p of x is x square and p of x is minus x square. In this case, if we compare it with the standard form, that is ax square plus bx plus c, it means b and c both are 0. If you represent these kind of two polynomials in the graph, you will notice that both have one common thing. The common point is 0, 0. Because when you substitute the value of x as 0, y will be 0. Here also if you substitute x is equal to 0, y will be 0. And since in this case b and c are 0, so this parabola is going to have 1, 0 and that is 0 itself. So this polynomial, the first one will go upwards because a is greater than 0, a is positive. Second case, a is negative, as well as since b and c both are 0, it is having only 1, 0 and that is 0 itself. So the second polynomial will come in this way. Okay. So in these two cases what we have observed, that the 0 of this polynomial is also 0 and 0 of this polynomial is also 0. But the first one opening upward depends on a is greater than 0 and second case when a is less than 0, in that case the parabola is opening downwards. Now we will discuss cubic polynomial and three cases I have shown over here. First is the polynomial p of x is x cube. Second is x cube minus x square and third is x cube minus x. If algebraically we see, further if you factorize, we have to make the polynomial as the polynomial equation. So p of x is equal to 0. Here x cube is equal to 0. It means that x is also 0. So there is only 1 0 of this polynomial and that is 0. In this case, if we factorize it further, x square is common. So x minus 1, again make its polynomial equation. So this will be x square, x minus 1 is 0. So either x is equal to 0 or this x minus 1 is equal to 0. So in this case, when x square is equal to 0, will give us the value of x as 0. And when x minus 1 is equal to 0, will give us the value of x as 1. It is a cubic polynomial. But how many zeros we are getting? Only 2. It means 2 zeros are same and 1 different 0. In this case, if we further factorize it, this will be p of x is common, x square minus 1, and if you further factorize it, it will be x. This is a square minus b square, and we know the identity a square minus b square is a plus b into a minus b. So x square minus 1 is x square minus 1 square. So x plus 1 into x minus 1. So we can write this as x plus 1 into x minus 1. Further, if you equate it by 0, we can get the zeros of this polynomial. So x into x plus 1 into x minus 1 is equal to 0. Now there are 3 zeros and all 3 are different because either x is equal to 0, that is the first case, or x plus 1 is equal to 0 will give us the value of x as minus 1, or x minus 1 is equal to 0 will give the value of x as 1. So what have we observed? In all 3 cases, all are cubic polynomial. But in first case only 1 0, Second case it is having 2 zeros. In third case it is having 3 zeros. It means all 3 points, the graphical representation when we will show the curve, all 3 points where it should intersect the x-axis will be coinciding, will give us one single point. Here the curve will intersect the x-axis at 2 different points. Here the curve will intersect the x-axis at 3 different points. So these are the 3 graphical representations of the cubic polynomials. First case only 1 0, that is the x coordinate where this curve is intersecting the x-axis, so its 0 is 0. Second case, it has 2 zeros. First is x coordinate of the origin, that is 0, and second is the x coordinate of second point. This point is here 1, 0. So second 0 is 1. In this case there are 3 zeros and all 3 are different. First is x is equal to 0, second is x is equal to 1, and the third is x is equal to minus 1. So all these 3 cases are telling us that a cubic polynomial can have at most 3 zeros, it can have 2 zeros, or it can have 1 zero. So these are the curves for cubic. Similarly, any curve, if it intersects the x-axis at 1, 2, 3, 4 points, it means this will be having 4 zeros. So similarly, we can say the point where the curve or the line touches or intersects the x-axis, the x-coordinate of that point will become the 0 of that polynomial. So what we have seen, the graphical representation of linear polynomial, quadratic polynomial, cubic polynomial, and similarly the polynomial in any degree. So this shows that if a polynomial has degree n, it can have n number of zeros. There are some specific terms about parabola. First case, the parabola intersects at 2 points. Second case, it touches the x-axis at exactly 1 point, and here you can see it is not intersecting or touching the x-axis. It all depends on a term called discriminant, that is D. The value of D is b square minus 4ac. When this D is greater than 0, in that case we can have 2 distinct zeros. And second, when D is equal to 0, in this case only 1 0, and when D is less than 0, this is the third case when the parabola will not have any real zeros. So these are 3 cases, 2 distinct, 1 same, and no real zeros. And we can also find out the point from which we take this term, means this point. So for any parabola, the point from where the curve takes the turn so that these 2 curves are symmetric towards a line, this point is called the vertex of parabola, and this line is called the line of symmetry. Okay. Now when we say the vertex, there are coordinates of vertex which can be found by this way. Minus b upon 2a and minus d upon 4a are the coordinates of the vertex where d is equal to b square minus 4ac. Now, sometimes a parabola comes in this way when the y-axis becomes the line of symmetry. In that case, the vertex will be the origin and its coordinates will be 0, 0. This is one case. Second case, it can be like this also. So, special is what? In this case, this parabola, both the sides, it is symmetric towards this y-axis. So, what we have seen, everything depends on this D. Whether we can have two distinct zeros or one zero or no real zero for parabola. Parabola means what we are discussing is a quadratic polynomial. So these are special cases for parabola or for quadratic polynomial.